For question number 9, you're given f inverse, you're supposed to find fx. But your answer will be in terms of k. And now we start by letting whatever that we are finding, in this case, fx becomes y. We rearrange or interchange it. F inverse y is now x. So 4 minus y over k is x. We are supposed to make y as a subject. Bring over, y is now 4 minus kx. What is y? Y is your fx, therefore fx is 4 minus kx. Okay, so you got your answer in terms of k and x. Part 2. Find the values of k and p if fx squared is now 2gx. Now I want you to remember fx is now 4 minus kx. If we replace x with x squared, I must replace this with x squared. So when you substitute inside, you should get 4 minus kx squared equals to 2 times of gx. Now what is your gx? Your gx is 3x squared plus p. Now as we can multiply inside 1 by 1, this will be 6x squared plus 2p. So what is a proper way? What is the correct way? Anyone? To solve for k and p. Yeah, we use comparison. By comparing the coefficient of x squared. Now notice I purposely rearrange it. I take this one, put in front, take this and put it at the back. By comparing coefficient of x squared, I can find k is negative 6, yes. And by comparing constant is the term without any x, I get 4 equals to 2p. Therefore, p is 2. Now, part B is related to modulus function. Now that I know k is negative 6, I can substitute inside my fx. Therefore, my fx is 4 minus 6x, which is 4 plus 6x. Okay, before we sketch the graph of modulus x, modulus of fx, can we draw this graph as y equals 4 plus 6x? The easiest way to draw a straight line graph is to use a table of values, x and y. Now, can we substitute with the smallest and the largest value of x, minus 2 and 2? If I substitute with minus 2, I will get 4 minus 12, which is minus 8. If I substitute x with 2, I should get 4 plus 12, which is 16. Isn't it? Now let us sketch. Now when you sketch a graph, please use a ruler. Your largest value of x is 2. Smallest value of x is minus 2. Okay? So when it's minus 2 is negative 8, let's say somewhere here. Okay? When it's positive 2, you get 16, which is somewhere here. Now I would use dotted line for the part of the graph that is below the x-axis. Use a dotted line. The one that's above the x-axis, we use a solid line. Okay. Now, whenever you sketch a graph, it's important for you to find the x-intercept and the y-intercept. Now we know at x-axis, y is 0. So if I replace y with 0, we can find x, right? X is negative 4 over 6, which is 2 over 3. Okay? Now it's not necessary for you to do this actually, but I like it to be such that it's quite easy for you to see all the points of intersection that we can calculate earlier first. How about this? At y-axis, x is 0. As I replace x with 0, my y is what? My y is 4. So it should look like this. Now this is a graph that I've got before you modulus it. It's 4 plus 6x. The moment you modulus this graph, what happens is the region of the graph that is below the x-axis, we have to reflect upwards. So now when it's reflected, negative 8 will now be positive 8. In fact, the entire line here, dotted line here, will now be reflected upwards here. Okay? And this is the graph of y equals modulus of 4 plus 6x. But we still have to state the corresponding range. Now remember, domain represent your x value. Your domain is given as between -2 to 2. Range represent your y value. And my y value in this case is from 0 to 16. Now notice I can't take this. In fact, I think I should erase this off. The smallest value of y that I have is 0. The largest value of y that I have is 16. Therefore, we can write our range as 0, y, 16.